students. In this class, we are going to discuss biodelignification. Biodelignification. So we know that the material lignocellulose. So it is a major constituent of plants. So which forms the complex matrix composed of phenolic polymers, proteins and polysaccharides. So we know that lignocellulose is an important major constituent of plants, which forms the complex material composed of phenolic polymers, proteins and polysaccharides. So we take an example of lignocellulosic material, rice straw. It is a rich source of lignocellulose. So rice straw is used as a rich source for lignocellulose. So the advantages of rice straw includes inexpensive feedstock, for biofuel production, inexpensive feedstock for biofuel production, most abundance, less cost. So raw rice straw is an important rich source of lignocellulosic material. So the advantages which include inexpensive feedstock for biofuel production, most abundance and less cost. So this, in order to produce ethanol, so this rice straw is used to produce ethanol. Ethanol will be acting as a biofuel. So for the production of ethanol from rice straw, so we have to remove the lignocellulosic material. So that is removal of lignocellulosic material. So there is a process of production of ethanol from rice straw. So there is a pre-treatment. So So the rice straw has to pre-treated. So the first one is alkaline treatment. Alkaline treatment. So alkalis such as sodium hydroxide, NaOH, calcium hydroxide, CaOH twice. So treatment of rice straw with strong alkalis which can degrade the ester bonds, glycosidic bonds, ester bonds and glycosidic bonds. So that alters the structure of lignin and structure of cellulose. And finally, decay of stability of lignocellulosic material. So, in order to produce the bioethanol from rice straw, so we have to remove the lignocellulosic material by pre-treatment method. So this pre-treatment method, which includes the alkaline treatment like NaOH and CaOH, alkalis are used to treat the rice straw, which degrade the ester bond and glycosidic bonds and alters the structure of lignin and structure of cellulose. So which ultimately decay the stability of lignocellulosic material. Next, we go for the production of biofuels by using biomass. So after delignification, so next we will go for second method is by using enzymatic delignification. Certain enzymes like cellulase, hemicellulase, ligninase. So these are the enzymes which breaks the cellulose, hemicellulose and lignin, which are produced by certain bacteria, produced by certain microbial organisms. Like yeast cells, etc. So the enzymes which are produced by the microbial organisms can degrade this cellulosic material and lignin material. The enzymes include cellulase, hemicellulase and ligninase. So these are produced by the microbial organisms like yeast cells or fungal cells. Yeast or fungal cells. So these are the different methods of delignification. Next, we go for methods of production of biofuels. By biomass. So there are different steps to produce biofuels by using biomass. The first one is gasification. Gasification. So here the biomass is subjected to heat, subjected to high temperature and low oxygen levels to produce biofuel, that is gasification. Next, pyrolysis. So heat is used to convert biomass into biofuels. That is second step, pyrolysis. Next, third one is digestion. So in digestion, certain organic matter gets digested by anaerobic bacteria, anaerobic microbial organisms in oxygen-free environment, which results in the production of a byproduct, that is CO2 and methane. So this methane is used as fuel, biofuel. So that is digestion. Next, fourth one is solid fuel combustion. In this, certain material like animal dung, peat are burnt directly to produce heat. So the heat is used to boil the water, and the steam produced from boiling of water is used to run the large machines like turbines and generators. So the methods includes for the conversion of biofuels by biomass includes, the first step is gasification, that is biomass to conversion, exposing of biomass to high temperature and low oxygen levels, that is gasification. Next, pyrolysis. Heat is used to convert biomass into biofuels, pyrolysis. Next, digestion. Organic material is digested by using anaerobic bacteria or anaerobic microorganisms in an oxygen-free environment, which produces CO2 and methane as end products. So this methane is used as fuel. Next, solid fuel combustion, in which animal dung and peat are burned to produce heat. So this heat is used to boil certain water. The steam coming from the boiled water is used to run large machines like turbines and generators. So limitations, which includes release of greenhouse gases, which ultimately causes global warming, and expensive to bring the raw materials and equipment, and large area is required. So limitations which includes the release of greenhouse gases, which ultimately results in global warming. And it is cost expensive to bring the raw materials and equipment for production of conversion of biomass to biofuels, and large area is required for this mechanism, for this method. So this is all about bio-delignification. Bio-delignification. So coming to bio-delignification. So we know that lignocellulose is an important constituent, major constituent of plants, which forms a complex matrix composed of phenolic polymers, proteins, and polysaccharides. So if we take an example of lignocellulose material, rice straw. So rice straw is a rich source of lignocellulosic material. So in order to produce biofuels, the biofuels like ethanol from rice straw, we have to remove the lignocellulosic material. That is called as bio-delignification. So coming to the advantages of rice straw, it is an inexpensive feedstock for biofuel production, most abundant and less cost. So for the removal of lignocellulose material, we have different methods. One is chemical treatment, in which we use certain alkalis like NaOH and CaOH twice, so which degrades the ester bond and glycosidic bonds, which alters the structure of lignin and cellulose. So which results in the decay the stability of lignocellulosic material. That is, chemical treatment comes with alkaline treatment. Next method is enzymatic treatment. Certain enzymatic treatment which includes cellulase and hemicellulase and ligninase. These are the enzymes which are produced by the microorganisms like yeast or fungal cells, which breaks the lignocellulosic material. That is enzymatic digestion. Next, coming to the conversion of biomass to biofuels. So we have different methods. One is gasification. So the production of biofuel is done by exposing biomass to high temperature and low oxygen levels. That is gasification. Next, pyrolysis. So pyrolysis is used to convert biomass to biofuel. That is pyrolysis. Next, coming to the digestion. In this method, the organic material is digested with anaerobic microorganisms in an oxygen-free environment, so which ultimately produces CO2 and methane as a side product. So this methane will be used as biofuel. Next, solid fuel conversion, in which animal dung like peat material are burned to liberate heat. So this heat is used to boil water, and the steam coming from the water is used to run the turbines and generators. Next, coming to the limitations. So conversion of biomass to biofuels. Which ultimately results in the release of greenhouse gases. Greenhouse gases, which ultimately leads to global warming. Next, expensive to bring the raw material and equipment required for the conversion of biofuels to biomass to biofuels, and large area is required. And the production of biomass, conversion of this biomass to biofuels includes, so the purpose includes used for producing solid, liquid and gaseous form of fuels. So the major purpose of using biomass, the conversion of biomass to biofuels, is production of solid or liquid or gaseous forms of fuels. Next, biomass is directly used for production of electricity. So this is all about bio-delignification. So here we have to remember, so the treatment methods, alkali like chemical methods and enzymatic methods for conversion of, for removing of lignocellulose material, which is used to produce biofuel. So rice straw is pre-treated with alkali or enzymatic methods to remove the lignocellulosic material to convert this biomass into biofuels. So we can use any of this method to convert the biomass to biofuels, either gasification or biofuels or digestion or solid fuel conversion. Any of this method can be used to produce biofuels. So after pre-treatment, we will go for conversion of biofuels to biomass. So we have certain limitations like release of greenhouse gases, which causes global warming, expensive to bring the raw material and equipment, and large areas required. And the major purpose of production of biomass, conversion of biomass to biofuels is, so we can produce solid or liquid or gaseous forms of fuels and directly used for the electricity production. So this is all about bio-delignification. In this we have completed bio-delignification. Thank you.